Module 8, Section 6.2, the simplex method. Objectives. Objective 1, set up the initial system and the simplex tableau. Objective 2, use the pivot operation on the simplex tableau and find the maximum value of the objective function. Objective 3, solve application problems using the simplex method. The simplex method, we wish to maximize the profit function subject to the constraints below. Maximize p equal to 5x1 plus 10x2 subject to 8x1 plus 8x2 less than or equal to 160, 4x1 plus 12x2 less than or equal to 180, where x1 and x2 are both greater than or equal to 0. The simplex method introduced in this section can be used to solve problems with more than two variables. Introduce like variables and rewrite the objective function. We had already seen this in section 8.1. Set up the initial simplex tableau. We had seen in section 8.1 how to set up the initial simplex tableau. The initial simplex tableau and reading the solution from a tableau. This is covered in section 8.1. Determine the pivot element. The most negative element in the last row is negative 10, so that will be the pivot column. And if we calculate the ratios 160 over 8, we will get 20, and 180 over 12, we will get 15. We take the least ratio, and the row containing the least ratio is the pivot row. So 12 is the pivot element. The pivot step. This is our goal. Use elementary row operations to produce a 1 in the pivot position and zeros elsewhere in the pivot column. Pivot operations. 1. Multiply the pivot row by the reciprocal of the pivot element to transform the pivot element into 1. 2. Add multiples of the pivot row to other rows in the tableau to transform all other non-zero elements in the pivot column into zeros. Let's do the step 1 here. Multiply second row by 1 by 12 to get 1 in the pivot position. Notice that we have 12 here as the pivot entry. So if you multiply the second row by 1 by 12, we will get 1 as the pivot entry. So what we are doing here is the second row is multiplied with 1 by 12. So all the elements are changing like this. So this first element here will be changing to 4 multiplied with 1 by 12. That will be equal to 1 over 3. So that is this calculation here. The second element will be 12 divided by 12. So that will be equal to 1. So that will be the pivot entry 1. So then we have the other locations. 0 multiplied with 1 by 12. That will give 0. That is this calculation. 1 multiplied with 1 by 12. That will be 1 by 12. That is this entry up here. Then we do have the next entry calculation, which is 0 multiplied with 1 by 12. That will be equal to 0. We are here. And finally 180 is multiplied with 1 by 12. So that will produce 15. So that is this 15 element here. So we need to remember that every entry of the pivot row is to be multiplied with 1 by 12, getting the new row which is up here. The remaining rows are simply copied. Step 2. Get zeros in the other positions of the pivot column by adding multiples of the pivot row to the other rows. So we need to get a 0 here in place of 8. So figure out a row operation to do that. So we have 8 here in row 1. So row 1 plus negative 8 multiplied with row 2 will produce that entry as 8 plus negative 8 times 1. So that will be 0 then. So this row operation is selected based on this criteria, getting 0 in that location. Let's do this row operation fully. So we are going to calculate the other entries of that row. So 8 is up here. So this 8 will be converted as 8 plus negative 8 multiplied with, we need to take the element from row 2, which will be 1 by 3. So when we do that calculation, this will be 8 minus 8 over 3. So that will be calculated as 16 over 3. So that is this entry 16 over 3 there. Then we have 8 becoming 0 through this operation. 8 plus negative 8 times 1 equal to 0, which is already done here. Let's do another calculation here. What happens to this 1? So that 1 will be 1 plus negative 8 times row 2 element is going to be 0. So that will become 1. So that will be the next calculation. So we do the same calculation at the other locations too. So this is 0. So 0 plus negative 8 multiplied with row 2 element, which will be 1 over 12. So that will be simplifying as negative 2 over 3. So this is negative 2 over 3 here. So the next entry will be 0 plus negative 8 times 0. So that will be calculated as 0. And the last entry is going to be 160 plus negative 8 times row 2 entry is 15. So I need to have negative 8 times 15. So when I simplify that, I will get 40. So that is the complete calculation of row 1. Now we are going to apply the second row operation, R3 plus 10 R2 changing R3. So if you think about how we get this one, we have a negative 10 here, which is in row 3, and I need to multiply the second row, which is the pivot row, by 10 and add to row 3. So this will be our 10 R2 added to R3. So that will make a 0 in that location here. Now we need to complete this row operation for the entire row. So that means I need to make calculations like this. Negative 5, which is the current entry here in row 3. And then I need to multiply the row 2 entry by 10. So I multiply 10 times 1 by 3. So when I do this calculation, I will get negative 5 by 3. So that will be the entry in the third row, corresponding to negative 5. Now going to the 0 location, that will be 0 plus 10 times row 2, that is again 0. So we will get that as 0. So a 0 is calculated. Here we have 0 plus 10 times 1 by 12. So that will be simplifying as 5 by 6. So that is this calculation up here. And then in the next location it will be 1 plus 10 times 0. That will be 1. And in the last location it will be 0 plus 10 times 15. So 0 plus 10 times 15 will be equal to 150. So that calculates this entry as 150. Again, remember that the row operation applies to all the entries in that row. We can pretty much copy the pivot row. Notice that x2 now becomes a basic variable. And this completes the pivot operations on the initial simplex tableau. Here we need to check for optimal solution. If there are negative indicators, that is negative numbers in the bottom row, we need to continue the pivoting operations. Here the process must continue because the bottom row contains a negative number. Select the pivot column, pivot row and pivot element as before. So that is, we need to select the column containing the most negative number in the bottom row. There is only one negative number. So this first column is going to be the pivot column. If we divide the elements of the last column by the positive entries in the pivot column, we will get these two ratios. 40 divided by 16 over 3, which is 7.5. 15 divided by 1 by 3, that will be 45. We always need to select the least ratio and the corresponding row will be the pivot row. So we get the first row as the pivot row. So 16 over 3 is the pivot element here. Doing the pivot operations again. So remember that 16 over 3 is our pivot entry. So we need to multiply the first row by 3 by 16 to get a 1 at the pivot location. So when we do that, so 16 over 3 will become 16 over 3 multiplied with 3 over 16. That will be our pivot entry 1. Notice how the other entries are changing. 0 multiplied with 3 by 16 will become 0. This entry here. 1 multiplied with 3 by 16, that will be equal to 3 by 16. This entry up here. Keep on multiplying the remaining entries with 3 by 16, getting negative 1 by 8 and 0. And finally 40 multiplied with 3 by 16 will be 7.5. That is step 1 of the pivot operations. Do the row operations to get zeros at the remaining locations of the pivot column indicated by the green boxes. This is our step 2 of pivoting. The calculations are done as follows. Multiply row 1 by 5 by 3 and add the results to row 3. Let's do the calculation here. Row 3 plus 5 by 3 multiplied with row 1 is replacing row 3. So that is the operation that gives 0 at the location negative 5 by 3. So if we do the calculations, we will get 0 here. Then 0 plus 5 by 3 times 0 will be again 0. To get 5 by 16, the operation will be row 3 entry 0, that is up here, plus 5 by 3 multiplied with row 1 entry, which is 3 by 16. So that will be calculated as 5 by 16. So that is this entry here, 5 by 16. One more, 5 by 6 plus 5 by 3 times element from the row 1 is negative 1 by 8. And when we do this one, we will get 5 by 8. That is this entry here, 5 by 8. And also the other entries. 1 plus 5 by 3 times 0 will be 1. 150 plus 5 by 3 times 7.5 will produce 162.5. We also need to get 0 in place of 1 by 3, that is in this green box. The operation for that will be multiplying row 1 by negative 1 by 3 and add the result to row 2. So I am going to write it as row 2 plus negative 1 by 3 multiplied with row 1. So that is how you get 0 in this green box. So this will be replacing row 2. The result is calculated as the second row in this final tableau here. Okay, let's do a few calculations. 1 by 3 plus negative 1 by 3 multiplied with element from row 1 is 1. So that will be 0. That is this location. So if I take the second entry, it will be 1 plus negative 1 by 3 multiplied with element from row 1 is 0. So that will be 1. So we get 1 here. Few more. 0 plus negative 1 by 3 multiplied with row 1 entry is 3 by 16. So when I do the calculation, I will get negative 1 by 16. That verifies this one. And we do the same kind of calculation to get 1 by 8, 0 and 12.5. This completes the pivot operations, and so decision time again. Since the last row of the matrix contains no negative numbers, we can stop the procedure. Assign 0 to the non-basic variables and read off x1 equal to 7.5 and x2 equal to 12.5. So we have x1 as a basic variable, x2 as a basic variable, s2 and s1 are non-basic variables. So our solution is S1 equal to 0, S2 equal to 0, and then reading the basic variables as X1 equal to 7.5, X2 equal to 12.5, and P equal to 162.5. Here are some observations. This flowchart summarizes the simplex method. Application problem. A farmer owns a 100-acre farm and plans to plant at most 3 crops. The seed for crops A, B, and C cost $40, $20, and $30 per acre respectively. A maximum of $3,200 can be spent on seed. Crops A, B, and C require 1, 2, and 1 workdays per acre respectively, and there are a maximum of 160 workdays available. If the farmer can make a profit of $100 per acre on crop A, $300 per acre on crop B, and $200 per acre on crop C, how many acres of each crop should be planted to maximize the profit? Here is a solution by the simplex method. The farmer must decide on the number of acres of each crop that should be planted. Thus we can take the decision variables as X1, which is equal to the number of acres of crop A. X2 will be equal to the number of acres of crop B, and X3 equal to the number of acres of crop C. The farmer's objective is to maximize his profit. If we denote the profit as P, we can calculate P as 100x1 plus 300x2 plus 200x3. Notice that 100x1 comes from planting x1 acres of crop A, that brings in $100 per acre of profit. So similarly 300x2 will be $300 per acre of profit of crop B, x2 acres of plantation. So it will be multiplied together. If we add all these 3 times, we will get the profit function. The farmer is constrained by the number of acres available for planting, the money available for seed, the available work days. This leads to the following 3 constraints. If we add all the number of acres, we will get x1 plus x2 plus x3 on the left side, and there are only 100 acres available for agriculture. So we will get x1 plus x2 plus x3 less than or equal to 100 as the first constraint. Similarly, 40 times x1 plus 20 times x2 plus 30 times x3 calculates the total cost of seed. And we only have $3,200 available, so we can actually write it as an inequality. 40x1 plus 20x2 plus 30x3 less than or equal to 3,200. We call that to be the monetary constraint. We only have 160 days of labor available, so converted to an inequality, that will be x1 plus 2x2 plus x3 less than or equal to 160. Adding the non-negative constraints, we have the following model for a linear programming problem. That is, maximize P equal to 100x1 plus 300x2 plus 200x3 subject to 3 constraints: x1 plus x2 plus x3 less than or equal to 100, 40x1 plus 20x2 plus 30x3 less than or equal to 3,200, and x1 plus 2x2 plus x3 less than or equal to 160, and the 3 variables x1, x2, x3 all greater than or equal to 0. Let's go through the simplex method steps. Here we introduce slack variables and form the initial system. We have 3 slack variables s1, s2 and s3 because there are 3 constraints. And notice that the objective function is written so that the coefficient of p is positive 1. Here we form the simplex tableau and start the simplex method. The pivot element is selected as 2 and do the row operation to make it 1. Here we do the pivot operations to get zeros in the rest of the pivot column. We need these 3 row operations to achieve this. Since optimal solution is not reached, continue with the pivoting again. Here 0.5 is the pivot element and x3 is the entering variable. 2 times r1 replaces r1. This row operation changes the pivot as 1. Do pivot operations to get zeros in the remaining positions of the pivot column, again marked in green. And the row operations are all shown here. Once we complete the pivot operations, we get this final tableau. All indicators in the bottom row are non-negative. And we can now read off the optimal solution. x1 is equal to 0, s1 is equal to 0, and s3 equal to 0 because they are non-basic variables. And based on this, the remaining variables will be x2 equal to 60, x3 equal to 40, and s2 equal to 800 with the p-value equal to 26,000. What does our solution mean for the farmer? If the farmer plants 60 acres in crop B, 40 acres in crop C, and no crop A, the maximum profit of $26,000 will be realized.